Imagine waking up one morning to find that your GPS isn't working, your satellite TV is down, and the northern lights are visible in Texas. Welcome to the fascinating world of space weather. Today, we're going to explore how events happening 93 million miles away on our sun can dramatically impact life here on Earth. Space weather is far more than just a scientific curiosity. It's a phenomenon that affects our technology, our safety, and even our modern way of life. Just as Earth's weather describes conditions in our atmosphere, space weather describes the ever-changing conditions within our solar system, particularly focusing on how the sun influences our near-Earth environment. The story of space weather research begins centuries ago, when curious minds first started noticing strange connections between solar activity and earthly phenomena. In 1724, a scientist named George Graham made an intriguing discovery. Compass needles weren't always pointing exactly where they should, and these variations followed a daily pattern. This mysterious behavior wouldn't be explained until over 150 years later, when scientists finally understood it was caused by electric currents flowing high above Earth in regions we now call the ionosphere and magnetosphere. But perhaps the most dramatic early evidence of space weather came in 1859, during what we now call the Carrington event, the most powerful solar storm in recorded history. During this event, telegraph operators reported sparks flying from their equipment, and auroras were seen as far south as the Caribbean, a sight that would be almost impossible under normal conditions. Fast forward to today, and space weather has become more important than ever before, as our modern civilization depends increasingly on technologies that are vulnerable to solar activity. When the sun releases powerful bursts of energy and particles, these can interfere with everything from GPS satellites to power grids, and even pose radiation risks to aircraft passengers. Let's break down exactly what creates space weather, starting with our star, the sun. The sun constantly emits a stream of charged particles called the solar wind, which travels through space at speeds of up to 1 million miles per hour. This solar wind carries with it portions of the sun's magnetic field, creating what scientists call the interplanetary magnetic field. When this solar wind interacts with Earth's magnetic field, it creates a protective bubble around our planet called the magnetosphere. Think of the magnetosphere as Earth's shield. It deflects most of the harmful radiation and particles from the sun, much like our atmosphere protects us from harmful ultraviolet radiation. However, sometimes the sun releases more powerful events called coronal mass ejections, or CMEs, massive bubbles of plasma that can contain billions of tons of solar material. When these CMEs hit Earth's magnetosphere, they can trigger what we call geomagnetic storms, massive disturbances in Earth's magnetic field that can last for days. These storms can cause beautiful auroras, but they can also wreak havoc on our technology. Let's look at how space weather affects different aspects of our modern world, starting with satellites. Satellites in orbit can be damaged or disabled by intense radiation from solar storms, leading to disruptions in communications, navigation, and weather forecasting. In 2003, during a particularly intense series of solar storms, 46 satellites reported problems, and one was a total loss. The damage occurs in two main ways: radiation damage to electronic components and spacecraft charging, where static electricity builds up on the satellite's surface. But the problems don't stop in space. These storms can have serious consequences right here on Earth. One of the most dramatic examples occurred in March 1989, when a powerful geomagnetic storm caused the entire power grid in Quebec, Canada, to collapse, leaving 9 million people without electricity. The storm induced powerful electrical currents in power lines and transformers, overwhelming the system's safety measures. This event served as a wake-up call about the vulnerability of our power infrastructure to space weather. Aviation is another sector significantly impacted by space weather. Airlines often have to divert flights away from polar routes during solar storms to protect passengers and crew from increased radiation exposure. These diversions can cost airlines hundreds of thousands of dollars per flight, but they're necessary for safety. GPS systems, which many of us rely on daily, can also be disrupted by space weather events. During strong solar storms, GPS accuracy can degrade significantly, affecting not just personal navigation, but also precision agriculture, surveying, and military operations. Scientists and organizations around the world work tirelessly to monitor and predict space weather events. They use a combination of ground-based and space-based instruments to watch the sun 24 hours a day, looking for signs of potentially disruptive activity. Satellites like SOHO and Stereo provide detailed images of the sun's surface and atmosphere, helping scientists spot potential threats before they reach Earth. Ground-based magnetometers measure changes in Earth's magnetic field, providing early warning of geomagnetic storms. The most advanced space weather forecasting happens at centers like NOAA's Space Weather Prediction Center, which provides alerts and warnings to government, commercial, and private users. But despite all our modern technology, forecasting space weather remains challenging. Unlike terrestrial weather, we can't send weather balloons into space to directly measure conditions between the sun and Earth. Instead, we rely on complex computer models that attempt to predict how solar events will interact with Earth's environment. These models are constantly being improved, but they're not yet as reliable as traditional weather forecasts. As our society becomes increasingly dependent on technology, the importance of understanding and preparing for space weather events grows. Scientists are particularly concerned about the possibility of another Carrington-level event occurring in our modern, technology-dependent world. The economic impact of such an event today could run into the trillions of dollars, potentially causing widespread power outages and communications failures lasting weeks or months. This has led to increased investment in space weather research and monitoring capabilities worldwide. In response to these concerns, many countries have developed national space weather programs and strategies. The United States, for example, has implemented the National Space Weather Program to coordinate research and operational activities across multiple agencies. International cooperation has also increased, with organizations sharing data and resources to improve global space weather prediction capabilities. Looking to the future, space weather will only become more important as humanity pushes further into space. As we plan missions to the Moon, Mars, and beyond, understanding and predicting space weather will be crucial for protecting astronauts and equipment. Commercial space activities, including space tourism, will also need to carefully consider space weather risks. So what can we do to protect ourselves from space weather events? The answer lies in a combination of improved monitoring, better predictions, and more resilient infrastructure. Power companies are installing equipment to protect against geomagnetically induced currents, while satellite operators are developing more radiation-hardened electronics. Emergency planners are also incorporating space weather into their disaster preparation scenarios, recognizing that a severe solar storm could be as disruptive as a hurricane or earthquake. As we conclude our exploration of space weather, remember that while we can't control what happens on the sun, we can prepare for its effects here on Earth. The more we understand about space weather, the better equipped we'll be to protect our technology and our society from its impacts. So the next time you see a news report about solar flares or auroras, remember that you're witnessing just one part of the complex and fascinating phenomenon we call space weather. Please like and subscribe for more videos like this. Be sure to leave a comment on what topic you'd like to see next.